Okay, so my presentation is entitled Using First Names to Predict Gender, right? So a bit of an overview. We're going to look at two research papers I came across while I'm doing some work in this area. And then I'll go ahead and explain the current work we are doing for on a permanent conference. And lastly, we'll take questions and I'll give any answers as suit. Okay, so the first paper is entitled Predicting the Gender of Indonesian Names, right? And this was a paper written by Ali Akbar Septandri, if I could pronounce that correctly. And essentially, this author proposed a method that predicts the gender of a name using character level LSTM, right? So in terms of a summary of this, the results reveal that when full names were used for the gender prediction, the author had a 92% accuracy, while only using first names would yield 90.65% accuracy. So it's a bit lower. Now, just to give a kind of background of Indonesian names, right? So these names and naming customs are essentially multicultural. It's polyglot in nature, and this is reflecting history and culture and so on from over 17,000 islands in the Indonesian archipelago. So Indonesia is the world's fourth most populated nation, and it's home to approximately 365 ethnic groups. And quite in fact, I didn't know this, but legally in Indonesia, a single name could be recognized as a full person name. So only your first name could be your full name. And this is true for the majority of Indonesians. However, you can actually have a full personal name as well. So it's based on your preference. So getting into the meat of the paper. So the author mentioned that some related work revolved around the creation of n-grams. So just to give a bit of what n-gram is, it essentially is a sequence of n words. And let's say, for example, TT Lab seminar, those two words there are considered a 2-gram. It's also known as a big gram. So the n-gram model is going to predict the occurrence of a word based on some n minus 1 previous words. So for example, given the sentence, please turn your homework in, if I were to construct a 2-gram from that sentence, it'll be please turn. The next one will be turn your, following you'll have your home, then homework, and then work in. So based on that transformation there, that's how machine learning models could build certain features and so on based on your data. So there was also some mention in research that converted the name to phoneme sequences before applying n-grams. So what this really is that given a name, so let's just say, just given Adam as a name, for example, if we were to take Adam and break it into the phoneme sequences, that might give us an indication of the gender based on how it's pronounced, right? And that kind of holds true for a lot of the base work in this paper, as well as other papers too. So the author proposed that given the success of LSTM, it could potentially bring benefit to the study. So in fact, with this doesn't require any n-gram extraction for this particular scenario. So idea of the data set used, so it consisted of 4,500 males, approximately that, and 2,300 females. The data set was not released for public use. So before applying the machine learning algorithms and what have you, typical process would involve removal of apostrophes, periods, hyphens. It would involve converting all your names to lowercase. And after that, essentially, we would go into either two branches. So the first branch would either be developing those n-grams, as I mentioned before. And then the other option would be to develop the first and last characters based on the phonetics as two forms of embedding for the problem. So onto some implementation details. He utilized Keras for implementing the LSTM, and the process would essentially comprise an embedding layer, the LSTM itself, and then finally logistic regression as the output layer. So the optimization routine was selected to be Adam with default parameters and a batch size of 32. And for both the embedding layer and the LSTM layer, the number of hidden units for this particular problem here was chosen to be 64, 128, and 256. And this was for full names. And with regard to first names only, he chose 32, 64, and 128 units, respectively. So for the LSTM, every index for each character was extracted and padded with zeros. And in terms of comparison with other algorithms, sklearn, was utilized for the remainder of them, except in XGBoost. So onto some results. So this here essentially is two graphs, and they show the best performance possible with this approach. So this is two samples of the top two performing essentially runs. And this would involve an accuracy of 92.25, as you can see below here, and an F1 score of 94.35. In terms of the right-hand side, was a bit lower, but almost the same. And I think what was varied here was that the embedding layers were a bit different in the size, right? So they more or less yielded the almost the same performance. So going back a bit, the data set was imbalanced. So I would consider F1 score to be the best predictor of the performance of the algorithm. Right. In terms of the other algorithms, we have utilized naive Bayes, logistic regression, and XGBoost. And we see that the best performance or accuracy in this case was from logistic regression with the 3-gram feature. And the F1 score was also the highest here with the logistic regression and 3-gram. And this is for, I believe this is for full names. And this here is the results for first name. So the previous one dealt with using the entire name, first and last name if they had any. And this one yielded the results for only first names. So again, the same 3 algorithms. And in this case here, the 2-gram performed the best with the XGBoost classifier here. Accuracy of 82.37 and F1 score of 87.8, sorry. Okay, so moving on a bit. So this is the second paper. So this one is a bit more recent. This was published, actually no, the first one was published in 2017, and this one was published in 2013. It's entitled, What's in a Name? Using First Names as a Feature for Gender Inference in Twitter. And this was presented or published by Wendy Liu and Derek Roots at McGill University. So essentially the paper was broken down into 2 contributions. The first one characterizes how incorporating a name can improve accuracy of a gender classifier. And the second contribution was a novel way of obtaining gender labels for Twitter users that doesn't require any analysis of the user profile or any sensitive data. So based on the presentation title, we'll be focusing on the first contribution. How are we gonna characterize incorporating the name to improve the accuracy of a classifier? So essentially, the evaluation for this paper revolved around the support vector machine. I believe they used the RBF kernel function. And essentially, they segmented the experiments into 3 approaches. One was the baseline approach. The second one was the integrated approach. And this was based on using the equation I have pointed onto the right here. So essentially, MX is the number of males and FX is the number of females. And this would be computed for each name in whatever data set that they used. Right? And this would essentially be, I think it's known as the name association score. And then lastly, we have the threshold experiments, which essentially was based off the integrated experiments. And what this threshold approach sought to do was that a score based on the integrated experiment had a weight or has a uniform weight, sorry, in the classification problem. So given some name, say name X, and name X occurred 10 times for male and 25 times for female, based on that, you could compute the mean association score as given here, right? So the thing is with this one is that, again, there's a uniform weight to the score. Now, if in any sense we had a name and that name occurred 100% of the times and it occurred female, we would want a higher preference or a higher weighting to be on the female classification. So the threshold experiments sort of apply sort of restriction parameter to actually allow overriding of the signal, right? So essentially, it's just a bit of an extension to the integrated approach. So in terms of some results, again, SVM were used. So again, the baseline approach, I didn't mention it, but this actually was essentially using other features from that Twitter data to predict the gender. And then the integrated and threshold experiments show the results or the improvement actually when we integrated the first name into that experiment. So with the integrated experiment, we saw a bit of a bump in the accuracy for males as well as females, and the average accuracy as well. In terms of the threshold experiment, it increased a bit more, but not so much significantly as opposed to the baseline. Just to give an idea of the data set used, I think they conducted this with 50,000 Twitter users. And from this, I think it was passed through Amazon Mechanical Turk. And then based on that, I think they were able to get about 12,000 confident labels, sorry. And then they would further validate this before doing any sort of testing. So that essentially summarizes this paper here. So in terms of my current work, so our work is essentially focused on essentially the Caribbean context, right? So we want to predict the gender for Caribbean names. So in terms of the first paper, there wasn't really any mention of the length of the first and last characters, right? So a bit back to that, based on the pronunciation of your name, if you combine characters, not only the first and last, if you combine the first two and the last two, you might actually improve the performance of certain classifiers. And then also as well, there's the intention to use character boot, and this is a character encoding technique. So potentially this would give us some additional boost in performance as well. And then lastly, the both papers here mentioned or made mention to treating the problem as a binary problem, but none actually treated it as a multi-class problem. So our approach or the work we're going to do is probably make this into a multi-class problem. So either you're male, you're female, or you're somewhere in the middle if you're not sure. And yeah, that's currently where we're at in doing the additional work. And that kind of brings me more or less to the end of my presentation today. So questions from anyone?
Yeah, thanks, Shiva. So yeah, so there's, I don't think you mentioned it, but yeah, this came about because we had some data and we were missing some gender information, so we tried to impute the gender information from the names. So it comes in handy. The thing is, so right now I'm involved in this part of this UNESCO thing, looking at ethics in AI, and so of course the question is when is it proper to take into account gender in making a prediction, and when is it not? And so it's this whole, and not only gender, but the whole bias, data bias issue, the fact that face recognition works poorly, not as good for Black and brown people compared to whites, because of less data, etc. So this whole issue about whether when to use gender information or other types of attributes is important. So it was just funny today. The Russian representative mentioned that we shouldn't be looking at gender at all, in terms of bias. But anyway, that was an interesting thing. So, but yeah, and I think it's an important issue. I guess most of you probably are familiar with the issue that Amazon had when they were processing resumes, and they were, based on that automation, they were hiring far fewer females and males. And that was because the data was biased, past data was biased. And of course, we have this issue throughout. But anyway, I just brought that up because the question always is, because we do this with insurance as well, right? We know that in the auto insurance industry, males are more risky than females. And so males should really pay a bigger premium than females. And the question is that the right way to go or not? And any thoughts on that by anybody? By the way,
I have strong opinions about it.
Yeah.
Because that's actually an issue I do have. Strictly speaking, that if you're gonna follow these ethical principles, you kind of have to follow them all the way through. So what I like as a methodology that I found pretty promising on possibly one day kind of solving this problem is that there's a paper that came out from Microsoft Research a few years back on counterfactual fairness. So what the idea is that they asked they basically, let's say for example, in terms of risk insurance, they would argue that there are some latent factors that really predispose someone towards being risky. So there's a latent factor you can't really observe. And it's kind of about if you can abstract like sort of a causal graph there, in a sense, to try to use that causal graph to kind of de-bias the outcome of the network, what the prediction it would make. Strange enough, it's despite it probably possibly being the bunny better notions of algorithmic fairness, I don't find a lot of people tend to talk about it too much. But to me, it makes sense, though, because you're pretty much asking like counterfactual questions about if how you be most fair to latent factors that these things are all just proxies for.
Right, but so I guess the question is really what is fairness, right? Because so you have these latent factors, but so let's suppose it's more dominant. Certain factors are more dominant in males than in females, and by gender that really tells you, well, males are more risky. The question is, well, if it's going to cost the insurance company more for males, then they should potentially charge them more, right? And
well, I mean, the gray area there is that legally, no lawyer will take up that as an issue, but based off of, my own personal interpretation of the letter of the law and the spirit of the law, technically speaking, they shouldn't be doing that, but you're kind of forced to because of our limitations, our current technological limitations kind of force that.
Yeah.
But it's something that, like, if you could one day eliminate it, because, like, say in principle, right? Somebody's riskiness, let's say as a driver, would be, conditioned on certain, like, say, behavioral characteristics, and everything that we do is we can't get a hold of those behavioral characteristics, so we have to use these rather low resolution proxies for those behavioral characteristics. But in principle, if one day we can actually get a hold of what those behavioral characteristics are, then it's kind of like a better mapping, I think, of the risk.
Well, no, I agree. Because
to me that is.
No, I agree, and in fact, the same thing holds for age, right? I think it's illegal to use age for certain decisions, but then you start removing more and more attributes, and so the accuracy goes down. So it's just an interesting.
I guess it's like.
Sorry. I was going to say, wouldn't this apply to insurance could be iffy if you want to be like sexist with gender with it in terms of charging different rates. But in other industries, like males would shop for different items, females shop for different items. Gender would play a part in like a recommendation system for that, supposedly. So I'm wondering if it if they look at it like a case by case thing, or if they uniformly want to get rid of gender as an input. I'm not sure if that could actually work in real life though.
Well, I think it really depends on the particular scenario.
Yeah.
I agree as well.
Because
Yeah,
let's say for a
the objective.
recommendation, let's say for a recommendation system, in effect, even if they don't use like a user profile, user model based approach, you just use like collaborative filtering that's just completely ignorant of any user specific aspects or attributes. You're still going to get, if you check the recommendations that are generated for a particular user, you are going to find that kind of a pair in a sense. But it's kind of like a matter of like it is like the potential harm of it, for lack of a better term. Like if you recommend somebody a product that they don't like, there's to me there's less harm in that. Versus let's say making let's say a recidivism. Let's say you want to predict recidivism. Right? Say the riskiness of a bad decision there is a lot higher than there's a product recommendation system, because you really decide, because if you underestimate the recidivism probability of somebody, you could put the public at risk. But if you overestimate, then that runs contrary to the what we would consider a notion of justice, right?
Yeah. Okay.
So,
good point.
Yeah. So I think it's like context dependent and whatnot. But I get you saying that it's the reason why we have to do these things now is because we don't know how to do it otherwise. Yeah. It's like with let's say with prescriptions. In principle, let's say like antidepressants. Some antidepressants make some people worse, right? But we only have current best practices because we don't know how genetics actually maps to which antidepressants are most apt for this person. So it's kind of like we don't have. Maybe the data exists somewhere out there, but we just don't know how to get it or to process it or to use it. But, it's kind of like a thing where, I guess it's where, these sort of like the whole objective of science is, right? Like we have to try to find better ways of doing things. And, unfortunately, this is what we have to do things. But, as time goes along, if we can get a way that's better, then, we use that way that's better.
Fair enough. I'm just wondering if in a lot of cases we're just using proxies to interpret gender as well. Like if you're doing customer clustering with different metrics, you may end up just clustering male, female sometimes without even realizing it.
Yeah, indirect attributes, and so that and especially when I get to bigger and bigger data sets where you have more and more attributes, even if you remove gender and age, you will still basically be doing the same thing, right? By these indirect attributes.
Yeah.
So it is a tricky issue. But yeah, anyway, sorry. Shiva, I have no more questions. Anybody have questions for Shiva?
Yeah, Shiva, I was wondering if you came across anything with predicting age from names, because I know different names have like different popularities in different decades.
Age from names? No, I didn't actually come across that. That was a quite interesting one though.
Yeah, because nobody really names are Gertrude anymore in the US, but that would be like anybody who has that name would be like 80 years old and over, most likely.
Yeah, I guess there may be some association. But certain kinds of names, at least, you might find some younger, some older. Yeah,
you probably need a lot of like historical birth data to do that model though.
It might be better to actually say, okay, given your name, you might fall into either a young or middle-aged or old category. That might be a bit better. Yeah, I'm predicting the exact age.
Yeah, just like a range.
Yeah.
That's cool though.
I guess an interesting bit with that would be like, are there phonetic trends within names that are popular during different periods of time? Because sometimes they say certain names are popular because of cultural factors that are kind of independent of what can be possibly extracted linguistically from the name. But at the same time, like say you hear a name, there is an intuitive notion that this is probably an older name.
Yeah. Right? So same way we kind of do it. I could probably learn something inside there.
Yeah.
Whether it's phonetic or it's just popularity that I don't know.
Phonetics actually.
No, I was just going to say, like, this is pretty good work. I'm pretty interested in this problem myself. I've been looking at this. You know, I had a problem once to classify male-female names in a couple of the islands a couple of years ago. Almost the same thing in Trinidad. We also looked at ethnicity and religion. And what I tried different things back then, but what I sort of ended up using was just pure heuristics, right? And Trinidad in particular, when you compare to like some of the other islands, Trinidad has like more sort of like ethnic diversity in the names.
Yeah.
So like Guyana is pretty much the same, right? You have that sort of ethnic diversity. And to answer what Inzimam was saying there about phonetic differences, for instance, like Hindi female names end in a vowel, for instance, right? If somebody has like a Hindi female name, most of them end in vowels. And that's just one of the little quirks that you get, that you see. One of the interesting things though, like that I had encountered was the unisex names. So this was a problem like Jade, for instance. Jade could be boy, Jade could be girl.
Yeah.
You know, you have a bunch of names like that there. But this is always, I've always been interested in like this type of thing. And you know, to answer the question of like trying to date names, I personally have been like running I have sort of like this little collection of, in Trinidad, it's difficult to get names from like the registry. I mean, if you ask them, you know, they would say all sorts of crazy things and, you know, not give it to you. But I've been looking at SCA, this being recorded, I've been looking at the SCA results. That's a very good data set. Gives you boy name, female, boy, girl names. And it's basically by, it's a large enough cohort, like about 18,000
every year.
Kids every year. And you could kind of like, you know, they were all born around the same time, right? And that is one of the things that I had looked up, I looked at and I continue to look at essentially. But this problem though, with respect to gender, in my mind, like I think it's something that you need to record all the time, because like bias that we're seeing now would be because of like imbalance in the training data. Like, you know, they just didn't have enough examples of females. And I think particularly when you consider, you know, the differing impact that like disasters, for instance, would have on women versus men, like in St. Lucia now, for instance, you know, trying to understand how women would be affected, COVID, you know, it's important to have that disaggregation at all levels. I think it's important that we include gender at all steps, and, you know, to take that, if not in the discovery and the exploratory analysis phase. And it's important to sort of like, so we could go back and audit and see, you know, if we are having any sort of implicit biases, and see where we could kind of like, you know, fill gaps essentially in what we're training on.
Now that you mentioned it, that thing about the Hindi names, I think there's a point in time in Trinidad specifically, your name would directly correlate to the day you were born. So, for example, in Hindi, the word for Monday is Sombar. The reason why I know this is because my grandmother, she was born on a Monday, and her name was Sum Ari. So Som, Var, meaning Monday, and they used to take, depending on the day you're born, they would somehow morph it into the name of the person. So depending on what days, Sombar for Monday, Mangalvar for Tuesday, go down the road. So, but I know that's for Trinidad at a given specific time. That I don't really think we do that anymore.
Yeah, and they would add that RE at the end, which is like a vowel at the end. So you see, I don't know where myself this sort of I don't know if it's just unique to Trinidad or anywhere else. I think we had tried to look for the records at the of the Fazal, the ships that came from India, the original ships, names essentially that you can go back and check. But I hadn't gotten around to doing that. But it'd be interesting to kind of like trace that and to see, because that you know, what Adidev just said is really interesting when you get into the etymology, the names. It's pretty interesting from a, I guess, a genealogical perspective, just going back and looking at, you know, names as fossil records, or, you know, when you were born.
Yeah.
But
Just to give an idea of current results, I think just some basic feature transformation and what have you, I have about 83% accuracy. And that's with XGBoost, I believe. And that's just with the phonetics. So first few letters, last few letters on a combination of some. So it's going fairly okay for now. So I want to try the character boot, especially to see the improvement there, if any at all.